Hi everyone, so this is a AMC 10 question number 25. So it's also a number 23 in AMC 12. So which meant to be quite a challenging problem. So since I'll try to make it a bit like slow, so you can speed up using the YouTube tool. So if you want to, but this is like I'll try to make it a bit slow. Okay. So the quadratic polynomial with real coefficient with the leading coefficient is 1 is called disrespectful if the equation of P of X is satisfied by exactly 3 real solution. Okay, so like, we have 3 solution of P of X. Like if the quadratic, like P of X is a quadratic, then if you plug that in another quadratic, so you expect to get a 4-degree polynomial, and then you are told only 3 real solution, right? So the fourth one should be a complex number then. But having quadratic in quadratic, if you just use the general form or standard form of the quadratic, it doesn't look like nicer to see because there will be too many unknowns with the 4-degree polynomial, which doesn't look like helpful. So which is why I will not use the standard form. And also we are told the sum of the roots has to be maximized. There's a special unique polynomial of those disrespectful quadratics, right? That's called the P bar of X. Then the sum of the roots will be the maximum. Okay, anyway, so before you really dive into this problem, it's really great to understand the question before you do anything. So I'm gonna just use let's say P of X, the equals, like I'm gonna use the factor form. So since we know the leading coefficient is 1, so we can just write the quadratic as X minus like R times X minus S. R and S will be our solution of this quadratic. So, and then this is if you make this equal to 0, so the X's will be R, X will be S, which my 2 solution for this quadratic. Okay. And if I want to do the P of PX, right? So let me write this as well. So P of X. So whenever I see X in this equation, I will replace with the whole P of X, right? Because that's basically what we do with the composition function. So that should be, maybe I'll expand this before we do this. So if I expand this is going to be X squared minus, if you expand this, you will get minus R plus S X plus RS. Okay. So now this is my P of X. And then I will replace P of X in P of X. Okay, so this whole thing is the same as this one. So I'm gonna write X minus R times X minus S. So this is P of X, right? And which will be replaced with this X, so minus R times the X minus R and X minus S minus S. Okay, again, make sure you really understand this part. Make sure you satisfy with this equation before you move on. So I replace with P of X, X with P of X, okay, to get P of X basically. So now we are told this polynomial will be called disrespectful if this has exactly 3 real solution. So we have a quadratic right here, we have a quadratic right here. If you expand them, because we already expanded one of them like this, and then that was gonna be like this part. So maybe I can just go ahead and expand it anyway. But if you have a 3 real solution, so the quadratic has at most 2 real solution, which means one of these product should have 2 real solution and the other one should have 1 real solution. So let's say this guy has 1 real solution, and then this guy has 2 real solution. Okay. So 2 real solution means the discriminant is larger than or equal to 0, right? So, but it's inequality, it doesn't really help much. But if I have a 1 real solution, that means discriminant is 0, which could be much helpful. So which is why I'll just use the first part. So from there, if I expand this one, which is I already did right there, so that was x squared minus rs plus, there's an x right here, plus rx, and minus r, this is the quadratic, right? And the discriminant of this has to be 0 if this has a one real solution. So let me write this discriminant, which is my b squared minus 4ac. So this has to be 0. So based on this, b is the coefficient of the x, which is minus version of this guy. Since I'm going to square this, minus will be plus. So the square of this guy will be r squared plus 2rs plus s squared minus 4 times a is 1, and then c is this whole thing right there. So times 4 times rs, and then 4 minus 4 times r, which will be 4r. And this has to be 0. So it doesn't look like really helpful if you are not careful enough, because we have 2rs and then we have minus 2rs, minus 4rs. Combine those, that will be minus 2rs. And if you combine with the other two square terms, so you will actually see those are equal to like r squared minus 2rs plus r squared plus 4r equals 0. So this is equal to my r minus s, so this is s, I guess, square. And this is 4r, maybe I can pull the other side, so that's going to be equal to minus 4r. Okay, so it is a bit challenging looking, but maybe I can take the square root, so that will be r minus s is going to be square root of this guy. I can pull 4 out of the parentheses, right? So that should be 2 square root of minus r. But since we take the square root, so we need to make sure we have plus and minus version of that guy. Okay, but it doesn't really look nicer so far. But we are told the sum of the roots will be maximized, which means r plus s has to be the maximum. So this is r minus s. Maybe I should find the r and s and combine them together. So let me try to find the s in this equation alone. So the s, if I make it alone, so that should be equal to r plus or minus 2 root minus r. Okay, so this is the s. So the r plus s should be, this is s. If I add r to this, so that should be r plus r plus or minus 2 root minus r. And this has to be maximum. So whenever you see a maximum or minimum problem, it's kind of a job for like completing square or AMGM like inequalities usually. But I don't want to really like dive into AMGM inequalities, since we are like dealing with the quadratic. So maybe it's better to use the complete square. But at the same time, there's no square term, at least obvious. Like there is one right here, it's in disguise, but we can see that if you are careful enough. So let me try to make a bit substitution. You know, this is the square root of r, this is the r, so which means r will be square of this guy, which looks like a square is coming on. So to make it a bit I guess visible, I'm gonna do a substitution. I'm gonna call this is x, okay? And if I square this, there will be negative r equals x squared. So r will be minus x squared. Okay. So based on this, maybe now I can just replace what I'm trying to make it maximum. So r plus r is this guy. So you have two copies, so negative 2x squared. And then plus or minus 2 times square root of minus r, which is x. So now, as you see, this is like a quadratic, so I can complete square. So if you're not really familiar with that, so maybe it's better to really review it, because I'm not going to dive into that. So I'm going to pull negative 2 to make it a perfect square term, and then that should be plus or minus x. I'm gonna leave some space. So again, I'll take the coefficient, which is negative, like negative or positive 1. Take the half, which is 1/2. So I will add 1/4, which is the square of that 1/2. And then I will subtract 1/4 as well. So if I just do the next step, so that should be 2 times. So the first 3 terms is the same as x plus 1/2 or minus 1/2 square. And then negative 2 times negative 1/4 is just 1/2. Okay, so that is basically 1/2. So this was like, this expression was r plus s. So maybe it's better to write it. R plus s is equal to this expression. Since this is the square, so this guy can be 0, but not negative. But if this is 0, then this is 0. But if this is not 0, anything you have for this guy will make a positive number because of square, and then you get a negative in front, so that will be a negative number. So which means r plus s will decrease if inside of this parenthesis non-zero. So to make this minimum, to make it this maximum, because otherwise it will getting smaller and smaller when you choose this inside non-zero. So the inside should be 0, which means x has to be 1/2 or negative 1/2. So if x is negative 1/2 or negative 1, positive 1/2, so x squared will be 1/4. So the r will be negative 1/4. So then r will be negative 1/4. So that is something, right? And then if r is this guy, so I can replace right here, because the question was asking p bar of x1, which means I just need x and like r and s. So if I plug r right here, so let me do this real quick. So the s value is equal to r, which is negative 1/4, and plus or minus the 2 times negative r. So r is negative 1/4, so that should be just 1/4. But what should we choose this for this, right? Should we just get a positive or negative? So, and I will just say this is 1/2 times 2 is just 1. So if I take the positive version of this, that will be negative 1/4 plus 1, which is just 3/4. Okay, since we want a largest, I guess, maximize the sum, so I'll take this 3/4. So we know s is 3/4, r is negative 1/4. So the p of x is now is known, so we can just replace right there. So p of x is equal to x minus r. R is negative 1/4. So 1 plus 1/4 will be times x minus s, which is 3/4. And based on this, if you just plug 1, right, for x, so that should give us our answer. So if you plug 1, so that should be 1/5/4. And then 1 minus this will be 1/4. So 5/16. So again, this is I guess one of the solution that I can actually come up with. So you may try something else, but I think for number 25, so this wasn't too bad. So I hope that makes sense.